1. So complement and supplement probably isn't the thing that tripped you up here. It's probably the degrees, minutes, and seconds. We know that complements add up to 90. So to find this, you have to do 90 minus the 37 degrees, 53 minutes, 1 second. Now, 90 degrees, this is 0 minutes and 0 seconds. So we have to borrow. You have to come all the way over to the 90. If you take away 1 degree, how many minutes is that?
60.
Okay, but I need some seconds, so I have to take away 1 minute, so now it's 59 seconds, or 59 minutes, and that is how many seconds?
60.
Okay, so then subtract like things. So 60 minus 1 gives me 59 seconds. 59 minus 53 is 6 minutes. 89 minus 37 is 52 degrees. So 52 degrees, 6 minutes, and 59 seconds. To find the supplement, you have 2 options. Normally when we talk about it, we just subtract from 180. And so we'll have to do the same thing. The other option, it's 90 degrees bigger than your complement. So you could just add 90 to the complement you found. But if we did this for practice especially, let's take away 1 degree, which brings over 60 minutes, but we need seconds, so we have to take away 1 minute for 60 seconds. So that's 59 seconds, 6 minutes, and 142 degrees. Is that okay? Question number 12. Okay, so I'm telling you these triangles are similar. I don't think I really read off all the answers on this, did I? You're supposed to find all the angles and sides. I think I just gave you the sides. Okay. So if these are similar, what does this angle have to be? In similar triangles, their angles are the same. So this would have to be, how would I find the third angle?
Add the triangles together and subtract them from 180.
Mm-hmm. So both of these are 44 degrees. Okay, now we have to find our sides. So if I call this side x, we know that in similar triangles the sides are proportional. So I could say like x over 75 equals, then I have to pick the corresponding sides on the other side, or on the other triangle. So that would have to be what? 20 over 25. So if you cross multiply, 25x equals 1,500. Divide by 25. We get 60. So that's this side. If I wanted to find this side, let's call it y for a minute. What proportion could I set up from this triangle?
Y over 10 equals 75.
There are different ways to set these up. The key is putting corresponding things together. So he did y from this one over 10 from this one equals 75 over 25. That works. You could also do like y over 75 equals 10 over 25. As long as corresponding things are lined up. So you get 25y equals 750. So y is 30. So we found all the missing pieces there. Okay, problem 13 says we have a triangle on a map. Has sides 9, 12, and 15. Okay, so that map corresponds to a real life triangle. The shortest real life distance is 122. So the shortest side of my map is here. So that means that is the shortest real life distance. Find the longest real life distance. So here was the longest side on my map, so this would have to be my longest side in real life. So then how could I set that up? Shortest over the shortest equals the biggest over the biggest. That would work. And you could also do like 9 over 15 equals 122 over x. So if we cross multiply, divide by 9, and this one doesn't work out perfectly. It's 203.3 repeating, or I think I put 203.33. That was our real life distance, which was measured in kilometers. Problem 14. The values of the 6 trig functions for an angle passing through the point 4, -2. Okay, remember, this means the x is 4, the y is -2. You have to find r. Some of you like to draw triangles. Totally fine. I didn't say you had to draw a picture, but you certainly could. If you think about the point 4, -2, that's right here. So if you're thinking about a triangle, it's this one. This is our angle. Okay, so then we can see that just makes it very obvious we have to do Pythagorean theorem, or x squared plus y squared equals r squared. So 4 squared is -2 squared. So if we square root, we can break 20 into 4 and 5. So that's 2 radical 5. Remember, r is always a positive number. X and y can be positive or negative. So then, we have to know our trig functions. What's the definition of sine?
Line for all.
Or if you think SOHCAHTOA, sine is opposite over hypotenuse. So -2 over 2 radical 5. The 2's cancel, but you can't leave a radical on the denominator. So you have to multiply radical 5 on top and bottom, which gives you negative radical 5 over 5. The reciprocal of sine is cosecant, or r over y. If you flip it, easier to flip before you moved your radical. The 2 still cancel and you just get negative radical 5 over 1 or negative radical 5. So cosine. Cosine is x over r. So that's 4 over 2 radical 5. Again, you can reduce the 2 and you multiply the radical 5 on top and bottom. So you get 2 radical 5 over 5. So secant, you flip it, r over x, or just do the reciprocal here. So that gives you radical 5 over 2. Tangent is y over x, or SOHCAHTOA, opposite over adjacent. So -2 over 4 is -1/2. That means cotangent, if I flip it, is -2 over 1, or just -2. So a question like this is worth quite a few points. Not only do you have to find x, y, and r, you have to know the 6 definitions. And when you're writing them, make sure it's in lowest form, no radicals left on the denominator. Is that one okay? And we didn't ask about 15, that one's all right? Let's look at 16F. Okay, find sine. Given that cosine is 2/3 and tangent is less than 0. All right, there's two different ways you could do this. You could do the Pythagorean identity, sine squared theta plus cosine squared theta equals 1, or you could set up a triangle. Which way did you guys do it? Pythagorean identity? When I say setting up a triangle, that's also just finding x, y, and r. So I'll show the identity and then we can talk about the other way. On the test, I might have one question where I ask you to use the Pythagorean identity. It will be this one, this identity, and I would give you the formula right now. So I might just say, use this to solve a problem, just to make sure you can. What we do is plug in the value we know. So we know cosine. So when I see cosine squared, that means take cosine and square that answer. Okay, so if I subtract over my 4/9, 1 minus 4/9, keep it in fractions, not decimals, that gives us 5/9. We have to square root plus and minus. So we have to decide, is sine going to be positive or negative? Why?
Because tangent has to be less than 0 and r cannot be negative.
Correct. We already know cosine is x over r, right? So I know my x is positive 2. I know my r is positive 3. R can't be negative, so it's not possible that I divided two negatives here. Tangent is y over x. If that's negative, that means y has to be a negative number. So that tells me that this sine has to be a negative number. I don't know the square root of 5. The square root of 9 is 3. So we get negative radical 5/3. That's one way of doing it. The other way is to do the x, y, and r. Okay, if we plug in x squared plus y squared equals r squared. So y squared is 5. Okay, again, y could be positive or negative, but if tangent's going to be negative, y has to be a negative radical 5. So then sine y over r would be negative radical 5/3. So two different ways. I didn't tell you how to do it, so you could do either of those. You could have also drawn a triangle and did the SOHCAHTOA definition, if that helped you. Is that okay? Let's look at H. So find cotangent. Given that cosecant is negative 7/4, and I told you it's in quadrant 3. So this one I would probably do x, y, and r. What's the definition of cosecant? It's a reciprocal sine. Sine is y over r, so this is r over y. I know r has to be positive, so r has to be positive 7, which means y is negative. Okay, so then if we do x squared plus y squared equals r squared. So square root plus or minus. If you're in quadrant 3, is x positive or negative? So x x is negative radical 33. So cotangent is a reciprocal of tangent. Tangent is y over x, so cotangent is x over y. So negative radical 33 over negative 4, and 2 negatives make it positive. So radical 33 over 4. You could have also, if you preferred, drawn a triangle. You're in the third quadrant. So sine is opposite over hypotenuse. So this would be hypotenuse over opposite. Found your other side and done the SOHCAHTOA definition. Any questions there? Let's look at 17. I want to know the sign. So I'm asking you, is this going to be positive or negative? Okay, so to do that, there's a couple ways. You can think, y over r. I know r is positive no matter what. 289, what quadrant is that in? Quadrant 4. This is 90, 180, 270, 360. So it's in quadrant 4. In quadrant 4, a y value would be a negative. So negative divided by a positive is negative. You could also use the all students take calculus trick. So the A is in quadrant 1, they're all positive. In quadrant 2, sine, and its reciprocal are positive. Quadrant 3, tangent, and its reciprocal are positive. Quadrant 4, cosine, and its reciprocal. So in quadrant 4, cosine is positive, which means sine is negative. All right, if I said cosecant of negative 181 degrees. You could think negative, so this would be going down, so negative 90, that's negative 180, so negative 181 would be here. Or, if you don't like thinking about the negatives, what could you do? Find your coterminal, add 360 to get your positive. And that gives you 179. So that is, again, quadrant 2. In quadrant 2, sine is positive, cosecant its reciprocal does the same thing, so it would be positive. C, we have cotangent of negative 539 degrees. I would probably add 360, but you'll have to do it twice here. And what does that give you? Grab a calculator if you need to.
Negative 169.
Okay, add it again then, so we get it.
181.
Okay, so 181 is just past 180, so that puts us in quadrant 3. In quadrant 3, tangent and its reciprocal are positive, so that means cotangent is positive. Or you could think in quadrant 3, this is x over y. Quadrant 3, x is negative, y is negative, 2 negatives make a positive. So no matter which trick you use, you should be able to figure that out. All right, question 19 is again asking us to think about these signs. Cotangent is greater than 0. Okay, greater than 0 means positive. In which quadrants is cotangent positive?
A and C.
A. C is for cosine.
A and T.
Yes. Okay, so it means I'm either in 1 or 3 right now. The second thing I know is that sine is less than 0. That means sine is negative. In quadrant 1, they're all positive, so sine's not negative. In quadrant 3, tangent's positive and sine is negative, so it has to be quadrant 3. Is that okay? Is this helping? I feel like Friday was a really long time ago. Problem 20. This is, I think, the only time on the entire study guide that I told you how I wanted you to do the problem. I said use the Pythagorean identities. On the test, I've already told you I'd go one step further and I would say use this Pythagorean identity. So I would give you the formula. We want to find sine if cosine is 4/13. So cosine, I'm going to plug in 4/13. That square just means I squared this. So 4 squared is 16, 13 squared is 169. If I subtract that over, I'm solving for sine, so square root plus and minus. In quadrant 4, is sine positive or negative? Negative. I think all students take calculus. Cosine's positive, so sine is negative. 153, that can be broken into 9 and 17. So that's 3 radical 17. 169 is perfect square, it's the square root of 13. So sine is negative 3 radical 17 over 13. All right. What else? Are there any other questions on here you want to talk about? Okay, so it says that sine is 0.5 and cosecant is negative 0.5. Okay, 0.5 is the same thing as saying 1/2. We know sine can be anything between -1 and 1, so this is okay. Cosecant is the reciprocal of sine. If sine is negative 1/2, what does cosecant need to be?
-2.
Would be positive 2, right? It would be the same sign if we just flip that 1/2. So it should be a positive 2, so can it be a negative 0.5? No. So that's why this one isn't possible. Another issue, cosecant has to be the opposite of sine, so sine can only be between -1 and 1. That means cosecant has to be smaller than -1 or bigger than +1. So it couldn't be a negative 1/2 anyway. But we also know at this time it would just have to be the reciprocal of 2. Tangent and cotangent, remember, can be anything. The others have limitations. Other questions? Do you want me to just put a couple problems on the board, see if you can do it? do on number 1.
Equal.
We have 2 choices. Are these things equal or are they supplementary? Yeah, these are alternate exterior angles. You don't have to be able to label that, but we should recognize they would be equal. Okay, so if you wanted, you could add over your 23, subtract over your 7x. So x is 7. You guys get that? All right, number 2, if I want to add those, we stack them up. So we add our minutes. That gives me 77 minutes. We add our degrees, so that's 98 degrees. Is that my final answer? No. If you have more than 60 minutes, we turn it into a degree. So we take away 60 minutes, add it over as a degree, so we get 99 degrees, 17 minutes. Number 3. If tangent is less than 0, that means it's negative. When is tangent negative? Right. It's positive in 1 and 3, so negative in 2 and 4. Cosine is greater than 0, so cosine's positive. In quadrant 2, sine's positive, so cosine's negative. Quadrant 4, cosine's positive. So quadrant 4. All right, number 4, how do we get our degrees, minutes, and seconds from this? So that gives me 41.07. So what I know is 132 degrees, 41 minutes. Then we take the 0.07 times 60. And that gives us 4.2 seconds, so that would be 4 seconds. Were those okay? We have like 6 minutes. Do you want me to put up some more, or do you feel confident? You guys are okay? So test is tomorrow. If you do have any more questions,